So I'm testing the wiring of a couple of light fixtures here. I want to make sure there are no ground faults or short circuits before I hook them up. And I thought this would be a good opportunity to demonstrate the usefulness of having a good insulation testing multimeter. First I'm going to test them using the standard method, which would be a normal digital multimeter. This is something that pretty much every electrician is going to carry. This will test voltage, AC/DC, resistance, continuity, diode capacitance functions, and amperage AC and DC. It's pretty much a do-it-all meter. I'm going to set this on the resistance function, the omega symbol there, to measure the ohms. And we're going to check first from the ground wire. And note that ground wire is attached to that big nut there. That's just grounding the metal, the framework of that light fixture. And we're going to check that to our hot wire here. And what I want to see in all my tests, I want it to say OL, over limit. I want that to be open circuit. If it says, see, I'll show you what it will say if it's a short circuit. 0.1. So if it says 0.1, it's pretty much guaranteed a short circuit in there. It's going to trip a breaker, wire's going to pop if I hook it up like that and apply power. So I'm going to test from ground to my hot black wire there, and it says OL. That's what I wanted to see. That's good. Okay, now I'm going to check between my hot and my white neutral wire there. 2.1 megohms. So that's a high resistance. I wish it was OL, but 2.1 megohms, that's not bad. That's livable. Okay, now we're going to check the same way using this insulation testing meter. Now this meter will put a voltage out, and it'll apply a voltage between 50 and 1000 volts DC, and that's adjustable. I can choose 500, 1000, 50, 100, or 250. And since these are 120 volt light fixtures, I'm just going to apply double the voltage, and we'll see what happens. Okay, remember this was OL, this test between black and the grounded wire was OL. So we're going to apply that 250 volts. It's actually 265 volts and now roughly 90 megohms. It's bouncing around a little bit, but that's pretty high. That's good. I'm happy with it. And turn a light on there, the backlight, make it a little bit easier to see. Now I'm going to check between the hot and the neutral. Remember that was a little bit over 2 megohms. Let's apply that 250 volts between the hot and neutral. Okay, see, we went from over 2 megohms to 0.1 at 99 volts DC. So as soon as we put an actual voltage on that, it broke down. So we've got a definite problem in the wiring in that light fixture. So this is not really trustable when we're doing that sort of test. Let's do the same thing for this next light fixture. We're going to check between the hot and ground. The backlight in that thing's not very good, but we have 8.25 megohms. Okay, so remember this one was OL, this was wide open, which was good. 8.25, that's, I'm concerned as soon as we put a voltage on it, a real voltage, it's going to break down. Okay, so now we're going to check between the black and the white. Okay, we got 1.9 megohms basically. Okay, we saw what happened before. So that's a high resistance, but I'm afraid once we put an actual voltage on it, it's going to break down. Let's check between the... Okay, now we're going to apply 250 volts. Yep, that went from over 8 megohms to 0.2, so that completely broke down. Let's check between our hot and neutral. Same test, 250 volts, actually 29 volts, 0 megohms, so that's basically a dead short circuit. So if I hooked them up, something's going to pop, breaker's going to trip, that'd be no good. So if I had trusted this, you know, I might have hooked these lights up and thinking they were okay, but now I know better. I actually applied a voltage, and now I know that the wiring needs to be replaced in both of these fixtures. Now to verify, I want to show you the actual voltage that these things put out. Let's see, I'm going to go over here and put this on voltage DC. A little backlight there. Okay, we're going to verify that that's actually putting out 250 volts. Actually, it's saying 265, and that's 264.4, so yeah, that's pretty much right on. And for the nerds out there, that 9.9 megohms, that's the input impedance of this meter. I'm not going to disconnect that. I am going to go over here and put that on ohms function, and we're going to check the output voltage of that meter there on the left. Put this on voltage DC. Okay, it's a little over half a volt. It's a big difference. You know, this is putting out half a volt to test the wiring. This is putting out an actual 250 volts, up to 1,000. So these are definitely worth to get. Keep on your service truck, keep in your shop. Yeah, they're expensive, but you know, if you want really good, accurate answers, you need to have the right equipment, and you kind of need a bit of everything. This one will do everything, but I'd rather beat this one up. It's far less expensive. I'll keep this one for doing measurements like this. All right, guys. Thanks for watching.